Hello, my name is Stefan, and in this lecture we are going to create our Makefile, compile assembly, and run our program. So here in previous lecture we just have this errors here, so I fixed this and changed this. We had the move here. I accidentally write it move as an instruction, but here you need to change it to pop. So this is the last final version of our code here, and I will share this on the lecture attachment sections, and that's it. So now we will clear the screen again, and as you can see we have kicking the ASM here. So we will create the gedit file. In this case we'll go to gedit. Actually we can also use the mousepad text editor, mousepad, the make file, and that's it. So here this is our mousepad. So we will first add, actually we can also add comments and so on, but however now we will here let's kicking actually it's far from the keyboard, so kicking here, and we are also kicking .o here, and gcc output file. So you learned that what this means in previous lecture when we compiled the hello world application, so I will not this failed in this lecture again. So kicking .o here again, we will also use the no pi, and after that we'll go to second line. So kicking .o here, this is also here. So kicking.asm, we will take this file, give it to an ASM. elf64 is going to be kicking.asm kicking.o here, and that's it. Save this make file here, and after that you can close this mousepad here, please, and make here, and as you can see here our make file is created, and our application is also filed. So this typing make here after creating your make file should compile and link your assembly code, and here you need to also keep in mind that make file. So here keep in mind that you don't use the spaces here, you need to use the tabs, and that's it. After that make, and as you can see is up to date, and that's it here. Now what we're gonna do is we will start our program and analysis, and we will start the analysis phase. So clear, and now let's start our kicking program, and as you can see hello world and alive. So in our first program hello.asm, we put the length of message here, mcg 13 characters, and in this rdx in order to display the message. And kicking.asm, we use a nice feature to calculate the length of our variables, as you can see here. So the message minus negative message 1 minus 1 part means this here. So take this memory location and here the dollar sign, and subtract the memory location of message 2, and the result is the length of message 2. So and this is the same applies for this message 1 here. So take this memory location and subtract the memory location of message 1. So the result is the length message 1. So that length minus 1 here, this is the string terminating 0, and it is stored in the constant message 1 len here, and note, keep in mind that the use of function prologue and the function epilogue in the code, so these are the needed for GDB to function correctly. As pointed out in the previous lecture, the prologue and epilogue code will be explained in later sections. And let's do some memory digging with the GDB here again, because we love that here. And now we will GDB kicking here, and that's it. So then at the GDB prompt, you type this is sample main, and that's it. So here this will show this output here. So on your computer, it seems that the variable message one sits at a location or somewhere on the byte, and here what we're gonna do is we will firstly check that x as 0, x 1 here, and as you can see, can access to at the address. So what we're gonna do is we will also try that with the message one with this and number one here, and as you can see here, it's hello world. And let's actually try the message 2, and this is the kicking and alive. So we got this memory addresses of message 1 and message 2 here, and we can also find the numeric values here. So in order to find that, we will again use xdw. So we will reduce it, radius, and here as you can see we got 357, and this is the radius. And now we get this p here, so radius and p, as you can see here, p is 7.13 here. Yes, and that's it. So we got this here. As you can see, it's the floating point number, and that's why we got a strange output here. And in order to fix that, we will instead of using x here, xdw here, so we can get this decimal and hexadecimal, right, value stored at the memory locations like radius and so on. And when we get a strange result when we tried to get this floating point variable and print it on screen. And in order to do that, we will not use d or w, we will use fg, and here after that we will pass p, and that's it. So this is the show sub, and we can also and the value with x here, and here p, and that's it. And this is our the size of the variable. And now what we're gonna do is we will firstly, actually, there's a subtlety that you should be aware of here. So to demonstrate, we will open this oops, we actually didn't created the LST using the Makefile. Let's actually do that again. So it's a pretty simple, just open Makefile again, that file here, assembly, project, as now we will mousepad Makefile. So now you will learn how to create this L file here. So in order to do that, we will just add just a slight bit modification here. So in the kicking.o section here, after this live.asm, right, we will add l kicking.lst. So because we need this file so much here for analyzing. Oops, go to assembly, Picking project, I'll make here and make it up to date as our base. So, that does. Yes. And as you can see, we got this kicking.ls TS here, so we didn't wanted that, but it's okay. There's a actually this file extensions didn't make much difference in programming, high level programming here, and that's why let's make it right. So rm kicking.lsts and rm kicking.o here s, and we will use the make ls, and as you can see we have this lsd file right here. So what we're gonna do is we will firstly open this lsd file with mousepad again, the kicking.lst, and that's it. So what we have here, there's a so what we have here, we have the sections and the memories here. So now you need to check this lines, line 10 and 11 here, and you will also need to check, yes, line and 11, and here on the left here you can find the hexadecimal representation of the radius p, and as you can here, and instead of 0165 you find 6501, and in this, instead of this which we got here, the hexadecimal number we got here, remember that, add it somewhere here. Actually, let's actually not make file again. Clear GDB. So here we will again get that value for you, so you can see what's the difference and where is the problem with that. So in order to do that, we will just go, for example, xd. Actually, let's get first a string and write that down here. Have string message 1, string message. Actually, but we first need this radius and pi here. So we know the value of radius. We obviously can see it here. Taking the lst, open mousepad. So here we see this variables and values, but there's a strange here. So there's something wrong. Actually, our program will work, but it has some warnings here. You need to learn what's that for. So I need to explain it to you. And now dw here, we will first get the radius. So with dw we get the radius's value here. In this case, let's actually reduce, but we don't need that. We already can see it. We will use xw, and again we will also use fx here for the p. Here there's the p here. That's it. X f p. Here, that's it. So as I said, instead of this 0165, we are seeing 6501. So this is the bytes, the 1 byte in 2 hex numbers are in reverse order. So this characteristics is called endianness. So the big endian format stores numbers the way we are used to seeing them. So with the most significant digits starting at the left, and the left endian format stores the least significant numbers starting at the left. So Intel processors use little endian, and that can be very confusing when looking at the hexadecimal code. So why do they have such strange names like big endian and little endian? So in 1726, Jonathan Swift wrote a famous novel, Bulwer's Travels. In the novel appear two fictional islands, so Lilliput and Blefuscu. Inhabitants of Lilliput are at war with the people of Blefuscu, but have to break eggs on the smaller end or on the bigger end. So Lilliputs are little Indians. So preferring to break their eggs on the smaller ends, and Blefuscu are big Indians. Not Indians, Indians. Now you see that the modern computing has traditions rooted in the distant past. So take the time to single step through the program, break main, run, next, and you can see that GDB steps over the function block. And edit the source code, delete the function prologue, epilogue, and we make the program single step again with a GDB. In our case, GDB does refuse to single step at the program. And when assembling with YASM, another assembler based on NASM, we can safely omit the prologue and epilogue code and step through the code with GDB. And sometimes it's necessary to experiment, tinker, and giggle around.